On the site of a bankrupt chemical company somewhere in Europe lies the boiler house of an old decommissioned coal power plant. The power plant once supplied the chemical company with electricity and heat. With a capacity of just under 40 megawatts, it was one of the smaller facilities. Yet, it was an essential core of industrial production. Join us in exploring this unique lost place. The entire site is undergoing deconstruction. Many buildings have already been completely or partially demolished. In the coming years, a new factory with more modern power generation will be built on the site. We visited the boiler house, the large building at the very back. Here the fuel, in this case coal, was burned to convert water into steam, which then drove turbines to generate electricity. For safety reasons, the turbines were housed in an adjacent building, which had already been demolished at the time of our visit. On this floor was the coal mill. The stored coal was fed into the mill through the hopper above us, where it was ground into fine coal dust. This fine dust was ideal for fast and efficient combustion, as the increased surface area of the particles allowed for optimal reaction with oxygen. The generated coal dust was blown into the combustion chamber, along with the transporting air using fans. There it formed a coal dust air mixture, which was ignited by a pilot flame. This process is known as powder firing and was specifically developed for consistent and efficient energy production. In regular full-load operation, both coal mills were in operation. If less energy was needed, one could be shut down, as each coal mill had 4 pipes, each serving all sides of the combustion chamber. In the combustion chamber directly in front of us, the fine coal dust burned at extremely high temperatures. The walls of this combustion chamber are lined with so-called water tube walls. These tubes contained water, which was converted into saturated steam due to the immense heat. The steam reached temperatures of around 250 degrees Celsius, depending on the pressure in the system. In many areas of the building, thermal cuts in the steel are visible. These deliberately created weak points were made in preparation for the planned demolition of the building. By strategically weakening the structure at specific points, it is ensured that the subsequent demolition can be carried out in a controlled and efficient manner. The delivered coal was transported to the upper floors of the building via conveyor belts. There, it entered the coal hopper, from which it was fed in a controlled manner into the coal mill. The saturated steam generated in the tube walls of the combustion chamber often still contained fine water droplets. These could have caused erosion and damage to the sensitive turbine blades at high speeds. To prevent this, the steam was directed to the superheater located further up. There, it was heated to around 500 degrees Celsius and converted into superheated steam. Superheated steam is not only completely dry but also has a higher thermal efficiency as it contains more energy. This made it ideal for use in turbines as it enabled a more efficient and safer energy conversion. The superheater consists of a system of thin-walled tubes arranged in areas of the boiler where the exhaust gases reach their highest temperatures. The hot exhaust gases flow directly between these tubes, transferring their heat to the steam inside through convection and radiation. The tubes are arranged in a serpentine shape to maximize the contact surface, ensuring the most efficient heat transfer possible. This design allows the steam to be heated to the required high temperature before being directed to the turbine. The superheated steam was then directed to the high-pressure turbine in the turbine hall. There, it released its thermal energy by setting the turbine blades in motion, converting it into mechanical energy. This mechanical energy was ultimately transformed into electrical energy via the generator. After passing through the superheater, where the exhaust gases transferred most of their energy to the steam, the now cooled gases were redirected downward in the boiler house for further use, such as heating feed water or warming the buildings. Subsequently, they were cleaned in the filtration systems before the remaining exhaust gases were released into the atmosphere through the chimney.